Hey everyone, how are we doing? Who all do we have in the chat? We gotta wake up Mewbot. Mewbot, wake up. Do I have my music now? I do have music. And we probably have no echo. I think we have no echo. Echo, echo, echo. Let's pop out chat and get the chat over here. I kind of like the new background. We went back to this old background here. Went back to the old background. And you know what? It's a good background. So, if you are here, feel free to say hi. And we can get some work going. Work. Let's see. Who has work? Who has questions? Let me know. If you have work, if you have questions. No one's in the chat yet. My Pearson login coming right up. Canvas login. Try to get some people over here. Reset my Canvas password, my Pearson password last few days. You never know. I think the camera looks better these days. I'm just gonna talk to myself. We try to improve the quality at all times here. At all times, improve the quality. Here at Stat 201. Oh, Noel, good morning. Good to see you there. You're here first. Let's throw you some big Mewbot points. Oh my gosh, I clicked the button. 30,000 points. I'm gonna go look at the assignment manager. I might email students and say, hey, if you didn't do the quiz or the homework, because we did the homework 5 part 1 last class and 151 students have done it, and a lot haven't, and a lot don't have good grades on it. So you can kind of tell who was in class and who wasn't, because if people were in class and they were paying attention, you should have at this point. It's all right. It's all right. I don't feel bad. So don't feel bad. But chapter 5, part 1, I know lots on the plate and lots to do. But we can get started on some chapter 5, part 1, especially the quiz. You start on the quiz here. I think a lot of people I could see how especially with a lot going on and we went quickly at the end. So I hope a lot of people can do it. That's my goal, is to take some of the work off your plate. So I'm hoping, and Noel, thank you so much for being here. So what should we do? Noel, what should we do? What should we do? You pick, we do it. That's what we do here at Stat 201. What should we do? Anything we do. I might send an announcement. It's all about all the time we have. We have a lot of time right now to do work. We have a lot of time to do work. Oh. Getting logged into Canvas. I'm gonna send an announcement to the class. Say office hours. Well, I have office hours live. Class link. I'm trying to finish the data analytics 3. Can we go over the part where the main write-up should be? Yeah, let's do the write-ups. Let's see. Here, I'll send that out here in a little bit here. Let's see, because we got tons of time. Let's do data analytics 3. Talk about the write-ups. And so I'm going to open up a different video right here. Open up this tab. And let's do it. Here we go. Okay, dokie. We are going to go and talk about the write-up for Data Analytics 3. But, so, oops, something went wrong. Oh, that's not good. Oops, something went wrong. Oops, all berries like that cereal. That's what went wrong. Warning, stream lower than bitrate recommended. Uh-oh. Okay. Put in the timestamp 5:05:13 and Data Analytics 3, Stat 201, Data Analytics 3, write-ups. Oh my gosh. Okay, so we're talking about the write-ups right now. Please go to the live videos right here. This might be the one where we covered the visualizations. Let's find out. That is not where we did the visualizations. You need to go over to live and click on them, see what we're doing recently right here. You can see right here, Data Analytics 3 getting started, Mosaic plots and side by side. We do go over a little bit here. So I'm wearing my black t-shirt right there. I have a lot of black t-shirts. That's my black V-neck t-shirt. And this is my black Batman t-shirt. So check this out right here, this video, and this is how to make the graphs. We're putting it in the chat right now. Also, the visualization playlist has videos going over each one of these. So we're not going to really focus on the making of the graphs right now, which I guess we'll kind of do anyways. We're going to focus in on analyzing the data. So here we go with doing some analysis of data. I'm going to open up some Pokemon data. And you will not be using this data. For my graph on the Mosaic plot, there is a section called the test. Yes, so we won't have to do the test section. Let's go ahead and make a analysis right here of seeing if a Pokemon is legendary or not by its type. And you can see right here, oh my gosh, let me subset so we don't get so many. I'm gonna go subset, and you will do your own subset. Make sure to follow the instructions. This is just about the analysis of a Mosaic plot, so we know what's going on. I'm going to type 2. I might have less. This is going to make a Mosaic plot because both variables are categorical. The learning objective right now is a Mosaic plot is the visualization of 2 categorical variables. A contingency table shows you the values inside the Mosaic plot so you can view them. Oh my gosh. Oh, no. Cancel, cancel, cancel. So many levels to this variable. We'll try one last time here. Does the type explain if a Pokemon is legendary or not? Okay, not the end of the world. So in this, what do we notice? The most likely Pokemon to be legendary is what? Tell me right here within here, the most likely Pokemon to be legendary is what? Do you see it? Look through the categories. The most likely Pokemon to be legendary is what? The most likely Pokemon group type to be legendary is what? This is how we would talk about it, and then we would give the percentages too. The most likely Pokemon type to be legendary is what? And I don't know is a fine answer if you don't know. So how would we look at this? Ice, nice job right there. Ice or water, I'll look at the water. Water's kind of high. It looks like ice is super high. You know, it's 40% of the ice Pokemon are legendary, where 25% of the psychic. So ice right here with this large blue bar is much higher than the other ones. Now, in your contingency table, you will only show the counts and the row percentages. So when you go here to ice, you can see that 40%, only 5, but 2 of the 5. So 2 of the 5 ice Pokemon were legendary. And the visualization up here shows it, and you can get the number of the conditional distribution by hovering over it. So you're asking yourself, is there a relationship? Well, yeah. It's like no bug Pokemon is legendary. I think there's one. He's like a fighting bug, I think. Maybe he's mythical. I don't know Pokemon anymore. There's too many. I missed the 151. So if you notice, there's no bug Pokemon that are legendary. There's no electric. There's no fairy. There's no fighting. This is a subset, so we are missing Zapdos and fairy legendary Pokemon. But Zapdos is legendary. And the legendary dog. Why can't I remember the name of it? So anyways, with this right here, in this subset, you see that ice is the most likely Pokemon to be legendary, where over here with things like bug, there are no legendary bug Pokemon. So I would see that there is an association. I see in your previous lesson you mentioned because the other one is wider. Oh, so with it being wider right here, it's that there's more water Pokemon. So this right here is the marginal distribution telling us that there are more water Pokemon. There was 26 water Pokemon as opposed to 2 steel. That's why steel is this tiny little sliver. The widths of the bars on the bottom tell you the marginal distributions of only one variable. Just like this here is the marginal distribution of legendary, which can be seen down here. There were 13 legendary Pokemon and 110 not legendary. That's not so much the bivariate relationship though, because it's in the margins, which is just what are the types of Pokemon and then what is the legendary status of a Pokemon. The bivariate relationship is inside of here, such that the conditional distribution of given a Pokemon is water Pokemon, what's the probability it's legendary? And it only has from this data set a 7.69% probability of being legendary. This is computed by doing 2 divided by 26. So that's of the 26 Pokemon, 2 were legendary from the water Pokemon. Same thing right here. There's 26 Pokemon within this. If I highlight it, you can see 26 are selected. It's not, oh, there it is over there on the side. I've selected 26 Pokemon, and only 2 of the 26 are legendary. It's the same sort of numbers just being shown to you here in this table. Now, you don't have to include the test portion. It is interesting. It is a chi-square test of independence, with the null hypothesis being that the 2 groups are independent and the alternative being that they are not independent. And we failed to reject the null because the p-value is above 0.05. It doesn't have anything to do with normality anymore because this is a test to see if the 2 groups are independent. We don't do this currently because this is one of the last chapters in the test on the the class and in the test on test 3. And so you don't have to include that. You do need to include your table, which will be smaller, and you do need to include the Mosaic plot. Any questions on this one, Noel? I'll put interpreting Mosaic plots. So you need to talk about those values right there. We could do a different data set real briefly. Remember, these are data sets I'm using, but you're not using, such as like the diamonds data set, which we did last time. And now we go here to, you'll take your subset, table subset, make sure you take the right size. You will take your own random sample size according to the instructions. And then I go to analyze fit y by x. Is the cut of a diamond explained by its clarity? And we do see some differences. Good morning, Braden. Good to see you there. Notice that the fair category only really exists mostly within this I1 group. So the fair cut is primarily only I1s. Now it's over here. It's over here. But that's a large portion. Also, IF right here is overpopulated with the ideal cut, as in there's a lot more ideal cuts. 77.78% of the IF clarity are the ideal cut, which is way higher than all the other ones, which if you look down here at the row percentages, and we're looking at the ideal is super high for this IF right here, and it usually hovers around 30 to 40%. As you can see right here, this is going to be one of the bigger ones at 45, and this is one of the 30-ish, probably 32%, and it's way more like higher percentage within that. So the things you need in your screenshot will need the following for your Mosaic plot. I like to put this over here. I click to the third button, check out the videos where I go through this a little bit slower. But in your screenshot, you will need both these things. You will need the Mosaic plot and the contingency table, and the contingency table should just have count and row percentage. This will be your screenshot right here. Check out the other videos too. But you will need the Mosaic plot. You will need the contingency table right there. And I've posted some links right here, the visualization playlist or the last office hours where we went a little bit slower and we did kind of the same things, but you need to talk about these percentages. And I beg this of you, I beg this, because here's where people make mistakes. You need to look at the rubric. At all points, look at the rubric for what it asks you to do. I try to remind students because a lot of times students say, what do we need to say? And I say, what does the rubric say? If you look at the rubric right here, you get points for putting your name and all this information at the top of the assignment. So copy paste that, put it in there. You need to take your random sample. Make sure you take the random sample according to the instructions. Next, you need to make your Mosaic plot and do the contingency table right there, the proper screenshot, which we just showed. Then you need to include write-ups that include numeric information and talk about the relationship. So this is the Mosaic plot and the start of it. Any questions on this? That's got the start of it. Good morning, Reptar. Ask questions. We are finishing up talking about the Data Analytics 3 right now. And we are starting a new section right now on interpreting side-by-side box plots. And with this, look what we need to do. Did you take your random sample? You'll get points or not points. Do you have a visualization and is it clear to see? Make sure to include it. Make sure to include your visualization. More on that in a moment. Write-up includes numeric information. Now I've got a pinned link at the top showing you where to go for the office hours where I do this really slowly right here. Notice we just opened up this window right here and you can see the office hours and you can watch me do the visualization on the side-by-side box plots, showing you how to do it step by step right here. So starting to get some views on that, but that is the visualization, and then the visualization playlist is also pinned there. The visualization playlist is always open and has everything right here, like making, I think this is making side-by-side box plots. So you can see how to make side-by-side box plots. There we go with the drag and drop. And I go through and explain analyzing the data. Oh, did they put, I think it put auto things in there. That's nice. Analyzing the data, data analysis overview. It's like the same thing everywhere. So check out those links. A lot of resources available right now, but we're going to talk about how to interpret the side-by-side box plots. So with this, I'm going back to my Pokemon data. First thing I'm going to do, which you need to also do, is take a subset by random sample of your random sample size. Make sure to do that. Now you're going to go here to graph builder. And then you're going to put your categorical variable on the bottom axis. And notice it puts the dots there. And then you put your quantitative variable right here, like the attack power of a Pokemon. Then you're going to click the box plots. And then you're going to click 5-number summary. And if you want, you could always go in here and put the categorical variable into color. And that gives you some nice differences between them. Now, I want to say this. Make sure to click done. So you have to click done. And then if you change the window size, it will change with it unless you've changed your graphic. Changing the graphic, Jump thinks that you want it to be that size. So if you change this graphic right here like this, then when you change the window, oh, it does still change. Well, other things don't do that. We have the 5-number summary now displayed for us. And what is super clear if you compare these right here? What is a thing you see immediately? So I would start, sorry, can you show more time with selecting the X and the Y? Yep, let's do it again. So we go here to Graph Builder. Under Graph Builder, you'll put in your categorical X variable and drag it down here to the X axis. Your categorical X variable of interest from your assignment will go down here on the X axis, just drag and drop. Next, the quantitative Y variable that we are interested in analyzing will be clicked on and then dragged and dropped. We did attack last time. Make sure you're picking the ones from your assignment, whatever semester you're watching this. You'll have different instructions, but you just want to grab the quantitative, which is the blue one right here, the one from your assignment, and drag it right here onto the Y-axis. You should now see side-by-side dot plots. We're not a big fan of dot plots here. We want side-by-side box plots. Go ahead and click the side-by-side box plots right here. And now you have side-by-side box plots. Sure, I'm just going to go to the original. Oh, that is the original. And now we're going to go down here to the very bottom and click 5-number summary. I've just, whoa. Whoa. Don't do that. Oh, whoa. Kind of like that more. Just like never messed with those settings. You can go here and go to color, put it right there, and then click done. And then make the graphic how you want it. Sure. Interesting. Different changes. I changed the width of the box plots. It's all preference in some ways. Just don't make it look crazy. Like if it looks bad to you, then it probably is bad. Any questions right now? And we need to analyze this and figure out what's going on with it. So what's going on with it? What is the analysis of it? What's happening here? What is like key differences you see? And you need to quote the values and compare the values. This is this and this is this. Give a value. This is 20. This is 10. They have a difference of 10. This is 50. This is 40. They have a difference of 10. This looks like a big difference. I think this is big. I think this is a small difference. The min is this, the max is this, or the min is this for this group, and the min is this for this group. I don't want to say too much because everyone writes exactly what I say. They start being like, the min is this. No, I'll be like, I observe for legendary Pokemon that the minimum attack power is 75 versus non-legendary Pokemon have a minimum attack power of 10. This is a huge difference where the minimum attack power of Pokemon is actually equal to the median attack power of non-legendary Pokemon. Does that make sense? And you can't really copy that because I don't think your median is going to be the same. That's just interesting that the median of non-legendary is the minimum of legendary, showing a huge difference between them because 50% of Pokemon for the non-legendary, well, the lowest legendary Pokemon is at the 50th percentile. Oh, I need that Rebel Braden. I'm trying to avoid them because I looked and the Coconut Berry Rebel has 78% of your daily sugar. And I just ate some gummies this morning, so that Rebel addiction is a tough one, man. I had a little syrup in my coffee, like that syrup. So, yeah, man, Braden, it's good stuff, that Rebel, but man, that's sugar. See, I should drink sugar-free Rebel, right? White Monster Energy, right? Yes, there's tricks around this. Then you just getting energy dope. Yeah, White Monster sugar-free. That's the one right there. That is pretty good. Maybe I might grab one of those. Those those can make me feel jittery and like prickly. Everyone's watching this now like, wait, where are we talking about data analytics? I don't know if they have, like, Celsius has like 2 to 4 cups of coffee in it or something. Celsius can make me woo. Maybe we'll do that. Maybe we'll do a white Monster Energy today. Maybe that'll be, we got to go to sugar free, macros, all that stuff, right? What should we do right now? Or is there questions on this? You just want to compare? I don't want to say too much here because the goal is to compare and contrast. Would we say false for legendary attack because there is more of a spread of or outliers? So what you want to do is you really want to compare the 5 number summaries to say, like, when comparing these 2 groups, we can see that for the legendary Pokemon, the lowest legendary attack of a Pokemon, the lowest attack of a legendary Pokemon was 75. This is way higher than the minimum for non-legendary Pokemon, which is 10, and is actually equal to the median for non-legendary Pokemon, which is 75. The median for legendary Pokemon is at 115, which is even higher than the Q3, the 75th percentile, for non-legendary Pokemon. But interestingly enough, the maximum for attack power for Pokemon is actually from a non-legendary Pokemon at 185, which is close to the maximum for the legendary Pokemon attack power. Now, I hope because I'm using different context, you can't copy exactly what I'm saying, but you notice how I'm just comparing and contrasting values, being like, oh, well, you know, like, legendary is higher in a lot of aspects, but the highest attack power in this data set is actually a non-legendary Pokemon with an attack of 185. That's a non-legendary Pokemon with an attack of 185, which is actually the highest, but it's only a little bit higher than the maximum legendary attack power Pokemon. The maximum attack power of a legendary Pokemon. There we go. Is that making sense, Noel? Like, the whole idea is like to compare the 5 number summary, like, oh, these are the same, these are different. And you can also find the IQR. The IQR for legendary Pokemon is found by doing 131 minus 100. See, everyone's going to write that. No. I'm going to read that in every report. The IQR is 31 for legendary Pokemon. 131 minus 100. And then, like, in parentheses. And there's millions of ways to write this. Make sure you know what the IQR is. This is slightly bigger than the IQR for non-legendary Pokemon, which is those numbers minus each other. I didn't error. No, that's right. 40.2. I should have just saw that. 40.2. I had 4.2. 40.2. How did you get the max Q3 exactly? Let's do that. When you're in Graph Builder, you can bring it back up by showing Show Control Panel. And you want to click this button down here, 5 number summary, and that'll make the 5 number summary appear. So make sure you have Graph Builder open or Show Control Panel open. And then when you have Show Control Panel open, make sure to click this button right here and that'll do it. Then make sure to click Done. No. Noah, let me throw you some points. Please ask every question. This is the point of office hours. And probably someone got stuck and is watching this video and being like, yes, throw a like on this video or a comment if these videos are helping you. Throw like or comment below. Smash like. Smash comments. That's what you do, right? So with this right here, I've heard from a lot of people, like, the questions during office hours help. Like, just someone asks a question and someone's watching later and they're like, oh my gosh, that's where that was at. I totally missed it. So yeah, don't not ask, because that's when you're like, yeah, ask every question. But if we can go on to something, we'll go on to something else if people want. We can do some chapter 5. Yay, Reptar. I'm gonna put like a Reptar on the screen. Should have like a Reptar appear and just like, rawr. I could get him to walk across the screen. Let's work on that little animation. Shouldn't be too hard to animate it. Just do like a path in After Effects. I wonder if I could do that in between class. Like, if I could do it in the next 35 minutes, but we gotta do work. It wouldn't be, you go into After Effects, you bring the image in, you put an effect, you add behind the effect a sound, and then you export with what is it called when it doesn't have graphic behind it? PNG. Export as PNG. Well, that's just the image itself. Alpha key. Never thought you have to learn this while teaching export with alpha key. Should we do chapter 5 part 2 quiz? What should we do? I'll put a vote. Chapter 5 part 1 quiz. Chapter 5 part 1 quiz. Chapter 5, part 2 quiz. What should we do? Or you can just say something in the chat. Part 2? Let's do part 2. Someone said it. That outvotes everybody who's voting. Replace questions. Here we go. We're doing the quiz. So if you're stuck on a quiz question, let me know. These are some of the tougher questions. Okay. Start from the beginning. Might be able to get a lot done. Okay. Back to the main screen. Chapter 5, Part 2 quiz. Okay. 26, 4 to 3, stat 2 to 1. Nope. Chapter 5 quiz, Part 2. And then use the normal model. Now, this question people get stuck on and they have no idea how to do. Can you tell me the z-score for 75? If you have an IQ of 75, what is your z-score? As in, how many standard deviations above or below the mean are you? What is your z-score? I've got a guess of it. What is your z-score? So remember, z-score is observation minus mean over standard deviation. Observation minus mean over standard deviation. Anybody? Well, it's how many standard deviations above or below the mean are you? So it's 75. Here, let me hit save on this. I just replaced it in normal curve file. So what was the mean of this data? What was the mean? What was the mean of this data? Anyone know the mean? Well, 0 is z-scores. Great job, Kylie, right there. That is z-scores. What's the mean of this data? It says at the very, very top, it says capital N 116. What does that mean? So the first number we get, yep, Braden's got it right there. The first number we get is the mean. And so you see right here, this is the standard normal curve with a mean of 0 and a standard deviation of 1. So the first number you get on this is the mean and then the standard deviation. And then we usually draw the normal curve with a mean of 0 and a standard deviation of 1 when we put z-scores on it. But I ask this of you. Go here and do the following. So now, this is review. What is the z-score of 75? What is the z-score of 75? What is the z-score of 75? Try to figure it out. See if you got it. I think Braden has it right there. And look, 75 would be right about here. And so Braden has it. Does that? And Braden, be careful though. Braden, I'm gonna throw you some points. Braden, be careful though. There'd be a problem on the test. I threw you some points though. I want you to catch it. Think about where it's at. So catch that little error. More points. Catch the little error. And then you can also show the math. The math is 75 minus 100 over 16. Kylie got it. Great job, Kylie. More points in the chat. So it would be 75 minus 100. I'll show the math right here. You're going to go 75 minus 100 over 16. And there's the answer right there because it's below the mean. And a z-score of 1.56 would actually be 125. And you say, Brian, how in the world did you actually figure this out that quickly? That it'd be wait, it's 100 minus 125 minus 100 over 16. How did I figure out that 125 is the z-score of 156? How did I figure out that 1.56 is the z-score of 125? Does anyone know how I figured that out theoretically? How did I figure out 125 is the z-score? Should have erased that. How did I figure that out? Any thoughts on how I figured that out? And I was like, oh, that's easy. Oh. Because 75 is 25 below, 125 is 25 above. They have a symmetric distance. So if you just go that much below, that much above, it's a distance of 25. It's the same distance exactly. Like you could do the same z-score, but the positive version on the other side of it, just by doing the other side. Like it's like negative 1.56 is 25 units below, positive 1.56 is 25 units above, because that's 1.56 standard deviations. So now here's the big question. It says, what percent of people have an IQ above this? So on the test, you might get pictures, and we would ask you to look at it and figure it out. So what percent do you think have an IQ above this? Somewhere between what and what percent? Somewhere between what and what percent? What do you think? It is apps. Somewhere between what and what percent? Don't worry about being wrong. Somewhere between what and what percent? And this is what you should be doing on the test. Like if you can do this, what I'm doing here, you know what you're doing. This is not about solving one problem. It's knowing how to solve all these problems. Because you'll notice it's the same sort of thing for every problem we'll do here. We'll do the same steps. So I found my z-score. Any guesses? How much of the area have I shaded? Don't worry about being wrong. Just take a guess. How much of the area is shaded right there? Is it more than 50%? Is it more than 99%? You can even look at it visually. We're asking how much of the curve is shaded to the right. So don't worry about being wrong. Just be like, I think this. What do you think? 96% is a goodish guess. And so here's the thing. How much area is below here? How much area is below this point, Braden? Below that point is how much? Below that point is 2.5. So what's above that point? What's above this point right here? So Braden, you might have you get a pretty decent guess right there. Actually, Braden, we got 3 big points because I think your answer is a possible answer. 97.5. And then how much area is to the right of here? Because we know how much area is to the left of here. Do you see what we're doing? How much area is to the right of there and how much area is to the left of there? Like as in, you'll see me shading over it, but how much area is over here? I'm shading over the area, but not all the green. How much area is that? 84. So the answer has to be, and great job, Brain, right there, adding up the arrows. Does it make sense that the area has to be between 84 and 97.5? Does that make sense? We know that now. The area has to be between that because it's not quite as large as this, which is 97.5, and it's not quite as small as this, which is 84. It's in between it. So your answer, Braden, Braden guessed 96%, which I think is a little too high, but it's a theoretical answer. So great job right there. More points in the chat. But what we're going to do right here is we're going to go to the applet. And you would be given pictures of the applet on the test, so you have to know how to look at these. We can actually enter in the data as is and look, whoops, not the right standard deviation. This is like now it's really easy, Brian. You go to find percent using X, make sure you've done that. And then we just go 75 and we go above. And look, your guess of 96% is really close and you can round to decimals. It was 94.1. Does this drawing right here, do these two drawings look kind of similar? Yes or no? Do these two drawings right here look kind of similar? Like that little tail right there where that spot is, the 68, the 84, the 100. What are your thoughts here for some points? Give me a yes or no. Do you think I did a pretty good job of drawing this out right here? There we got to draw it out. So I'm happy with myself. I would say yes, exactly. So this is where we can get a good estimate, but the applet's going to show us the exact answers, and it's round to 1 decimal, so 94.1 is the answer. Now it wants below 85, and you know what? We can probably guess this one. Think about where 85 is basically at on this curve. 85 is a z-score a little bit less than what on this curve? 85 is a z-score a little bit less than what on this curve? 85 is a z-score a little bit less than what on this curve? So look over at the left or the right. 85 is a z-score a little bit less than what on this curve? Where's 85 at? It's a little bit less than what? 85 is a z-score a little bit less than what? So you want to look down here at this number line? Well, yeah, I see where you're, maybe. Tell me in z-score terminology. Well, the z-score of 2 is over here. Oh, are you talking about down here? I see what you're saying down here, but look where 85 would be at. 85, it's right around -1. If you look at where 85 is at, 85 would be right about there. So now the area should be a little bit what to what. Think about the area and what we know, and if we want to go below, and the area should be a little bit what to what, and then take a guess at it. The area should be a little bit what to what when we say below 85, which is a z-score of about -0.93. We could find it if we want. We could say observation minus mean over standard deviation, -9.4-ish. The area is going to be a little bit what to what. So use context clues on here. Well, so the area is the amount of areas shaded on the curve. So when we say what % of people would be expected to have an IQ less than 85, we're asking from here down, what % of the curve is shaded? And we can use the empirical rule, numbers, to help us out. And we've added these numbers to the curve. Make sure to have your drawing. Please replicate the drawing on the left over there to be able to do it. So what % of area is shaded on this curve? Is it less than 50%? Is it more than 1%? What would be a guess of this area? And then how would you get that guess? The more you see it, like when you start to see it, it starts to make sense. And that's what I want to, because I can tell you the answers and I can show you the answers, because this is going to give us the exact answer right here. And once again, you won't use the applet on the test. You'll see pictures of the applet. Any guesses of what % of the curve I've shaded right there? And how'd you get the guess? Let's get one guess, right or wrong. We're going to get one more guess. Give a numeric guess. Noel, that's a really good guess. Yes, Braden and Noel. I bet if we were to average your guesses together to about 17%, that's a really good guess because it's a little bit more than 16. Really good guess. We're going to go below and go below 85. I say 17%, and it's 17. I'm not even joking. Look at this. Watch this. 18.7 plus 16 divided by 2 is literally, that is literally your guys' answer. Like within, yeah. There you go. And Noel's seeing it right here. It's a little bit more than 16%. You can also add these areas down below, which are the areas between each thing. But is that making sense why that's a little bit more than 16? Like, do you see it visually to be like, yeah, that's going to be a little bit more than, I'll post down Reddit. That's going to be a little bit more than 16%. Is that making sense, Braden and Noel? That's what we want to see. And that's like, oh, this is the exact answer. So we're just going to grab this right here, bring over here, drop in, and then it wants between two values, 120 and 136. So now between 120 and 136, it's a bit trickier of a one. 120 is here at a z-score of 1.25 because that's 4 divided by 16, or 20 divided by 16 is 1.25. And then what did it say? 120 to 135? Where'd that go? 120 to 135, right? 136. This is a tougher one. Ooh. I mean, that kind of looks like... Anyone got a guess of how much that is? Who's got a guess of how much that is? This would be a very hard one to guess. Then you can just get the right answer by clicking between and doing the answer. But just take a guess. I'm going to see if you get a closer guess than me. I'm guessing... I don't want to tell you my guess right now. I'll say it once you say yours. Okay, I got my guess. I have my guess. What do you say? Take a guess. Don't worry if you're wrong. Don't worry about being wrong. Noel, you might have got the perfect answer. I think 15%. So you probably have a good guess. So we're going to go right here and go between 120 to 136 it was. And it's actually smaller than we thought. And notice you were actually closer than me, Noel. So let's throw you some more points. 120 to 136 to one decimal right here. Noel, you were closer. It's very hard to guess those little small ones, but we were close. We knew it was small. And so you add that in right there and you check answers and you get 100. These questions have people stuck for forever. They say, how in the world do I get them? Well, one, we can make drawings that give us a good guesstimate of what's going on, and then we can use the applet to get the exact answer. Notice I overdrew the size of it. So you would have to use calculus without the applet, but the empirical rule lets us make estimates. Does that make sense, Braden, right here? Like we were to estimate looking at the empirical, it'll be like, 13%. Sometimes we say use the empirical rule on the test. Sometimes we give you a picture, check out Canvas content for practice problems. Actually, you know what? Let's show people what it could look like. Here, we'll do that. We're going to do a Canvas content chapter 5 problem. We've actually done it during class, but it doesn't hurt to like see these problems on the way they'd look on the test. So let's actually do that here because I didn't do it. Did I do it? I didn't do it during office hours yet, did I? So let me do Canvas content number 5, which is 8 days away. But chapter 5 is people get stuck on it and they have no idea what to do. They say, I am stuck. I'll just lose points. And I say, no. Okay, let's go do it. Here's Canvas content number 4, chapters 5 and 6. Never mind, don't want to use the calc. Yep. So this is the first one right here. We've already covered this in our class. When doing a normal probability plot, how does a normal probability plot tell us if a distribution is normal? A, B, or C? How does a normal probability plot tell you if a distribution is normal? Does anyone know? Ooh. Pretty normal. Maybe, here, I'll try to find one that is not normal. That one's pretty normal. Trying to find something worse. Normal distributions are unimodal symmetric. Unimodal symmetric. My gosh, they really normalize Pokemon distributions. Special attack. Let's go to price of diamond. We see how straight, that's exactly it. This line right here, this line is the perfect normal. And if your dots follow the line, it's normal. And you can see that one is a pretty normal distribution. Whereas we go over here and do analyze distribution on price, which I think you already did. And if we make a normal probability plot, you can see this one is very not normal. So I'll put them side by side right here. On the left, you see a normal distribution, which the curve for it, a histogram, is unimodal symmetric. And on the right, you see one that doesn't follow this line. You can actually use that line right there. So you see this line right here, that is the perfect normal line, and your data does not follow it. So if you look at it, the line right here, the data, that's weird, jump. The data does not follow it. Meanwhile, this one, the data follows line. Does that make sense? Like if you look at the linear nature of that versus the linear nature of this, the normal probability plot lets you see if your data is normal by seeing if the data follows the line that dictates kind of what is normal. Of course, a unimodal symmetric histogram is going to follow the line better than a right skewed or left skewed or something weird. Last but not least on this one, you do have what is called a goodness of fit test. A goodness of fit test literally fits the normal curve on top, hence continuous fit of a normal curve. And you can see down here, tons of stuff is given to us, but we want to do the goodness of fit test. And the answer is this is a bad fit. And I'll explain why here in a moment. So I'm going to do it for this distribution too real quick, just so we can talk about goodness of fit, continuous fit, normal, and then go right here and goodness of fit test. And so what you want to do for this is look at this and ask, does that normal curve fit the data well? You see it bulging out right there. and it's not filling out right there. It's like if you got jeans and you're just nothing fits. Like this jeans that don't fit. Bad jeans. You want new jeans. And with this, we would reject normality. It's right behind my head. But the p-value on the Shapiro-Wilk, names of the people who did it, goodness of fit test comes back very low. And the data is from the normal distribution. Small p-values reject the null. You reject the null that the data is normal. We go into more detail on that on other classes. At this point, know that a goodness of fit test is used to test normality. And when the p-value is low, you reject that the data is normal. That's not for all p-values, though. Let's look at the next question on the Canvas content and see what it asks. So it follows the line. The line of data is straight. Okay, so here we are with an applet question people get stuck on. So with this right here, the first thing you want to do if you get one of these is what it out. The first thing you want to do if you get one of these is what it out. What word am I looking for? I'm going to start doing it right here. What are you going to start doing on this? What are you going to start doing? Draw it out. Braden knows right there. You're going to draw it out. What do we mean by draw it out? Any of the information up top, you're going to start putting down below. Notice how it says that between 97.14 and 99.26, or outside of it, is 13% of the data. Notice how this is symmetric. What percent of the data is there? What percent of the data is on either side of it? It's symmetric. So since it's symmetric, what percent of data is on both sides? You got it, Noel. Great answers. All we did was cut this in half because it's being distributed to both sides. So we go right here and do 6.5%, 6.5%, and then 87%. How in the world did I get 87%? How did I figure out 87%? Any thoughts on that? Which I don't even need, but sure, whatever. How did I get 87%? Exactly. It all has to add up to 100% if you go across the whole curve. So we got 87% right there. So you know what? It asks, what percent of observations are higher than 99.26? So what's the answer? You could ask different questions like what percent are higher than 97.14? What percent are lower than 97.14? What percent are between 97.14 and 99.26? What percent of observations are higher than 99.26? I'm just drawing it out. It wants this shaded area right there. 6.5%. That's all it is. If you know how to read it, that's big question right there. That's it. Next one, we get what's called a correlation matrix. Correlations range between -1 and 1. The weakest correlation is going to be the one closest to 0. So all this question is asking you, of all these numbers, what number is closest to 0? If you know weakest correlation means closest to 0, all you have to do is find the one closest to 0. What's the answer? We haven't covered this yet, but weakest correlation means correlation closest to 0. So if you're taking notes, write that down. Which of these correlation values is closest to 0? Positive or negative? Just closest to 0 means weakest. Could be like -0.1 or close. Let's throw you some points right there. Check to see if there's something a little bit lower than that. And we're talking closest to 0 in absolute value. Close. Close. I see one lower still. So on the test, I would literally go across and be like dot 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 dot. Okay, is that the lowest? Is that the closest to 0? Is that the lowest? Remember, closest to 0. Don't worry. I'm throwing points. We're trying hard at this. We got this. Do you see any other values that are closer to 0? I'll show you a trick on this too. On a correlation matrix, it's actually symmetric. Any values lower than that. It's symmetric, so the values repeat on either side. So you only have to look at one side of it, if that helps narrow down your field of view. Kylie, great job, Kylie, right there. Yep. That's the lowest. And then what you want to do is you want to like go across and be like, are any other ones lower than that? So the concept is weakest correlation is closest to 0. So find the value closest to 0. Positive or negative doesn't matter. That's the direction of a correlation. Strength is absolute value. One of these is the way we talk about univariate data. So that is the answer. Which one of these is the way we talk about univariate data along with center spread? So when we talk about univariate data, we're talking about something center spread. And then bivariate data is strength, direction, form, unusual features. So when we talk about bivariate data, which has correlation for quantitative, we'll talk about strength, direction, form, unusual features. But univariate data is something center spread. So it doesn't go along with the bivariate descriptors. And we have 3 of the 4 bivariate descriptors. Shape. Shape is univariate. It goes to the shape of the histogram. So when you talk about a histogram, there is the shape of it, the center of it, the spread of it. And then when you talk about bivariate data, bivariate quantitative relationships have a strength, direction, form, unusual features. This is a somewhat strong but heteroscedastic, fun word, it changes in strength, a somewhat strong, somewhat linear, positive relationship. That's the direction. Direction positive, strength moderate to moderate strong, hence by the high R squared. And form somewhat linear, a little nonlinear bend at the end, and unusual features, outliers, and heteroscedastic. Chapter 6, more on that. Which of the following is a bivariate display of quantitative data? Go ahead and answer in the chat. Which is a bivariate display of quantitative data? Which of these is a bivariate display? So there's the univariates up there. Here's bivariates inside of here. Blue means quantitative, green means categorical. Scatter plot, that is true. And a scatter plot or a time plot is a special case scatter plot that has a time on the x-axis. So scatter plot. We can do one more version of this. Remember, this is your office hours. It's whatever you want. See if we get different stuff. But like people get stuck on the canvas. Ooh, who can do this one pretty quickly? First, find the z-score of running a 31-minute race. Here's the mean and standard deviation. What is the z-score? It doesn't ask the z-score, but it doesn't hurt to practice. So what is the z-score of a 31-minute race? Z-score formula is observation minus mean over standard deviation. So what does that equal to? It doesn't ask the z-score, but never hurts. What is the z-score? We have the observed is this. Have the mean is this. What? Is it 3? Double check as I write the wrong things. Double check. Yeah, exactly. You messing with me. You messing with me. Thank you, Braden, right there. Just seeing if I'm paying attention, right? So it's 31 minus 25 over 3 equals 2. So no worries. And then back here, what do you notice about a z-score of 2? What percent of runners take longer than a z-score of 2? So use the information on the screen for what percent of runners take longer than a z-score of 2. What percent of runners take longer than a z-score of 2? Exactly. You just go right here. You don't even have to write your numbers down here of like 25, 28, 31. You can if you want. It doesn't hurt. Then you can see the z-score really quickly. Is it making sense? Like drawing this graphic is like, whoa. I need to get that going. Like the mind-blowing thing. I need to make that a button. I keep thinking every semester. Above 31 minutes, 2.5. There we go right there. How's the normal probability plot tell us? Line is straight. Which of these is not? Shape. Lowest, weakest correlation. Not lowest, but weakest in terms of absolute value. Strongest negative. So strong correlations are close to 1 or -1. So which of these is the strongest negative? See if you can find it. I think these questions, if you know how to do them, are just free points. Because strongest means closest to -1 or 1, and the negative means it has to be negative. So which of those is the strongest negative? If you know how to do them, it's free points. Yeah, I think it is, right? Let me double check. I entered the absolute value of it. Yeah, don't do that. That's it. That's the one that's negative and closest to -1. And you can see right here, I'll pull up the graphic from Wikipedia. They have an amazing graphic that the strength of the correlation is how well it aligned would describe the data. And so positive or negative, it doesn't matter, doesn't impact strength. These are both equally as strong. So if it's -1 or +1, it's the same strength, it's just a different direction. As in -0.8 has the same strength as 0.8, it's just a different direction. And then 0 is the weakest linear correlation, but watch out, it doesn't mean there's no relationship, because these are relationships like a kind of sigmoidal or sinusoidal relationship. Sigmoidal is an S shape, sinusoidal is a sine wave. So weakest correlation, this is chapter 6, we're being a little preview of it. Weakest correlation means closest to 0. So these are all weak correlations. Strongest correlations are closest to 1 or -1. Negative correlations are just what they sound like, negative. Does that make sense? Like a negative correlation is negative. A strong correlation is close to 1 or -1. A weak correlation is close to 0. But correlation only means linear relationship. It doesn't mean there's no relationship, because all these down below have a correlation of 0. They have no linear relationship because they don't follow a line. Well, it just depends on what we ask. If we say negative, it has to be negative. If we say weak, close to 0. If we say strong, 1 or -1. But if we say strong positive, then it would be close to 1 because it denotes a strong relationship that has a positive value. So notice there's these little like add-ons that we can do to them, like a weak negative correlation would be a correlation that's negative and close to 0. A weak correlation is the closest to 0. A strong positive is closest to 1, which would be way over there. Does that make sense, Noel? Like strong means closest to 1 or -1. Negative means negative. Positive means positive. Weak means closest to 0. So something like a weak positive relationship would mean it has to be positive and close to 0. So just understanding what the words mean of like weak, strong. People usually get confused because like -1, how is that strong? Well, it's just the way it works. So with that, did we finish the quiz? I think we did it. Maybe we'll do another speed run on one more. 10 out of 10. Might have time for one more quick speed run of this. So that's a z-score of -1, which is 16% below, because 68, 32, half of that. That's the one we did before. That's 2.5. A p-value for correlation which is statistically significant implies that the correlation is due to random chance. No, it implies it's not likely due to random chance. Low p-values are impacted. Low p-values mean unlikely due to random chance. Correlation is always impacted by outliers, so it's false that it's not impacted by outliers. If the correlation of two values is close to 0, this implies no relationship. True or false? If the correlation is close to 0, this implies no relationship. True or false? If the correlation is close to 0, this implies no relationship. So answer it to finish office hours here. If the correlation is close to 0, this implies no relationship. True or false? If the correlation is close to 0, this implies no relationship. True or false? If the correlation is close to 0, this implies no relationship. False. It implies no linear relationship. So it's false because correlation only measures linear relationships. So it could be true, and Braden and Noel, great answers right there. It could be true if it says a correlation of 0 implies no linear relationship. That's true. But if it says no relationship, that's false, because correlation only measures the linear strength between two quantitative variables. So good stuff right there. Really good. And those are the trickier questions. And then knowing how to look at the graphic right here where you can see these are relationships that are not linear and they have correlations of 0. Now there is the kind of no relationship, which is that one right there where there's no, it's just randomness. And that would also have a correlation of 0. With that, we'll be back here shortly for more Stat 201. Bye for now, everyone. Bye. Hey, Noel, I'm just back real quick because I think you need the dark mode video. Sometimes Macs have an issue where the numbers don't show up. And so I'm bringing up the dark mode video. Here it is, right? I'll show you, and I'll send it to you, and let me know if this helps. I think this is it right here. It can have issues. So this is the link right here to the dark mode video. And sometimes numbers don't show up until you turn on dark mode. I don't know why. It's just issues on Macs. Yeah, so that might fix it. Let me know. But there's been issues with dark mode. So let me know. Bye for now. Bye.